Okay, motor calculations for electric exam. This is for my community college class, ELT242. This is steps 5 and 6. This is a short video, probably shorter than others, but you need to watch 1, 2, 3, and 4, those videos to figure out what this one's about. Alright, you will need to get your code book out. Once you got it out, we got some highlighting to do, but basically it's almost a review. You're going to see what I'm talking about. Tables that will be covered. Step 5, find feeder wire ampacity. Steps 5 and 6 is for multiple motors. Let's say you've got a feeder wire and you're tapped onto that feeder wire and you ran 3 motors off of it. So it's kind of like the bus duct in my shop. You know, we pull on the table, we'll pull 3 or 4 motors down. Well, the feeder is supplying each branch circuit's wire motor. So we've got to upsize it. We know the branch size wire. We got to find out what the feeder wire is going to be and how to size the breaker on it. So this is steps 5 and 6. It's sections 430.24, sections 430.62a. That's 5 and 6. Okay, step 5. This is what's going to blow you away. Step 5, all it is step 3 plus all other motors FLC. So what you're going to do is take step 3, you're going to find the largest motor and find the amperage on it and multiply it times 125%. That's step 3. And then you're going to take all the other motors that's on that line and add them to that. So if you have a motor, you find that the largest one, and like I just said, you find that largest motor, multiply it times 125%, and then add all the other motors to it. It's not hard at all. As you can see here, FLC, let me get my, there it is. FLC, the largest motor, 125% plus all other motors equals feeder ampacity. Of course, you may have to find the wire size on some of the questions. You know, you may end up getting the feeder wire ampacity of 104 amps. What size wire do you need? Well, it depends on the installation. But step 5, all it is step 3 plus all other motors full load current. Sample question, what is the feeder ampacity for a 5 horse, a 3 horse, and a 2 horse, 230 volt single phase motors? Okay, this is an obvious one. There's others that may be tricky, but to me the obvious largest motor is the 5 horse. So I'm going to look at it. And okay, 5 horse, it is 28 amps. That's the largest motor. We're going to multiply it times 125% and then add the full load current of the 3 horse and the 2 horse. But while I'm at that table, I'm going to go ahead and get the 3 horse and the 2 horse ampacity. And they are 17 and 12. So what do? 28 amps, that's the largest motor, multiply it times 125%. Step 3, right there, that's step 3. And we're going to add 17 and 12 to it. So we got 64 amps for it. It's not hard at all. Okay, here's one. You need the wire size. What size feeder conductor wire with THHN installation will be needed for a 2 horsepower and a 7.5 horsepower 230 volt single phase motor? Well, this one's easy too. The largest motor should be the 7.5. It pulls 40 amps. The 2 horsepower pulls 12 amps. So what are you going to do? 40 amps times 1.25 plus 12 gives us 62 amps. 62 amps is not the answer because they're asking what size wire we need. So what size wire will handle 62 amps? Well, table 310.16 says a number 6 copper conductor will be needed. So number 6 is your answer. Okay, here's the last one on step 5. What's the feeder ampacity of 2 10 horsepower 3-phase 230 volt motors and 1 single phase motor? And that's a tricky one because the 3-phase motors, they're handling all 3 lines. Well, the 3 horsepower motor, single phase, is just tapped off 1 line. So we're going to handle off of 1 phase, and that's going to be your largest conductor. So that's what we're going to size and base it on. That way the other two phases will be the same size wire. But what is the feeder ampacity of two 10-horse motors? They're 28 amps each. Well, the 3-horse 120 amp is 34. So you're sitting there thinking 10 horse, that's the largest motor. It is not. The 3-horse 120 volt pulls 34 amps. So we're going to take the 34 amps, multiply it by 125%, and then add 28 and 28. So we got 98.5 amps. So watch out. The bigger horsepower does not always mean the largest amps or the more amps. That's step 5. Step 6, it's just as easy. All step 6 is step 4 plus all other motors full load current. So if you can do step 4, if you can do the video for step 3 and 4, obviously you can do the video for 5 and 6 or the questions. So step 4, what it says is take the largest branch circuit breaker protected motor and add all other full load currents to it. So we're going to step 4, what size dual element fuses we need? Well, you're going to take and do step 4 and find the breaker that you need. It ain't the ampacity, this is the breaker. So if the ampacity is 48 amps, you're going to use a 50 amp breaker. Well, 50 amps will be the number you put in plus the ampacity of the other motors. So you take the breaker size or the fuse size and add the other motors to it. Sample question here, same as the step 5 question, 5 horse, a 3 horse, and a 2 horse. The largest motor is the 5 horse. So we're going to take the 28 amps and we're using dual time delay fuses. So time delay fuses, if you do step 4, we've got to multiply it times 175%. We get 49 amps. So we're using 50 amp fuses. 50 plus 17 plus 12 gives us 79. Here is the big deal. On feeders, you've got to go down. You can't go up to the next size breaker. You've got to go down. So this one says 79 amps. You would think, well, an 80 amp breaker will cover it. Well, you got to watch that. You've got to back it down to the 70 amp. And what if the question says 75 amp? You think, well, 75, that's the answer. Well, it's not, because 75 is not a standard type breaker. Remember, it goes by 5s up to 50 and 10s up to 110. So you got a 70 amp and an 80 amp. There's no 75. And sometimes they'll throw that curveball out there to you. But this is a 70 amp fuse. That's the end of this one. I mean, these are super easy, steps 5 and 6. I used to be intimidated by them because, you got multiple motors. But all they are step 3 and 4 plus all other full load current motors. So if you can do step 3 and 4, you can do steps 5 and 6 if you can add. The summary of the 6 steps, you've got to know step 1 almost every question every time. You've got to establish that base of full load current, and then you add and subtract, from that, the multipliers. But step 1 is real easy because you got a chart. Step 2 is easy. You got to remember those multipliers and service factors and things. Step 3 is easy because you go whatever the full load current is, multiply it times 125%. You may have to go find a wire size every once in a while. Step 4, there's a chart that tells you the multiplier. And step 5 and 6, you do step 3 and 4 and then add other motors. So these ain't hard. Don't let these intimidate you because they're easy. I would recommend you tab your code book to step 1, step 2, or full load current, overload, breaker size, branch wire. You don't have to tab 5 and 6 because all they are step 3 and 4, and if you can remember to add the other full load currents. So you got 4 tabs to put in there. Put a big highlighter square over the overloads, maximum, minimum, the chart for the full load currents and the breakers. That way when you turn, you've got them right there. But these ain't hard. I hope you learn them. You got ampacity, I think we got motors, we got ranges. I've got to do conduit fill. That's going to be one of the videos in residential. We'll wind it up after that. Hope y'all have a good day. If you got any questions, holler.